So, to begin with, I am re-recording because I think I can do this even better. I started last hour with a bunch of review, and I realized I should have done even more review. So we're going to start by reviewing. We're not going to start by factoring trig identity problems just straight up. We're going to start with plain old-fashioned factoring. And we're not going to take trig and do common denominators. We're going to start with plain old-fashioned common denominators. So go off to the side, and let's just do 1/2 plus 2/3. Do you remember how to get a common denominator and add these things together? Because today it's going to be trig on the top and the bottom. We got to be able to do it with normal numbers first. So Brady, what's a good common denominator for these things? 2 would not work for a common denominator. We want to get a common denominator, so a denominator that'll be like the same for both of them. So I'll give you a reminder. You want to multiply by the other denominators. Yes, 6. So we're going to multiply by 2 and 2 and 3 and 3. Because see, if we multiply by the other denominator, then you end up with a denominator of 6. And then just, again, because right now I know it's easier, and you're probably thinking this is too easy. But 3 plus the 4 makes 7 over, you don't add these, do you? 6 and 6 doesn't make 12. When you're adding 3 6 plus 4 6, you get 7 6. The bottom doesn't change. Why do I say that? Because when you're adding with trig, the same thing's going to happen. Your denominator just stays the same. You don't add the denominators. 3 6 plus 4 6 is 7 6. And I think you get that, but so many kids don't think about that, and they just try to add all the way across, and they add the bottom too. Don't add the bottom. All right, another thing, and I didn't feel like I needed to say this, but I'm going to anyway. If you had to get a common denominator here, there is no denominator on one of them. So what do? You'll put a 1. And then, what do? Well, you don't really need to times this side over here by anything. Do you get, sometimes you can just leave one of the sides alone? See, if I multiply by 2 here, do you get they already have a common denominator? I didn't have to multiply the other side by anything. So now this stays as 1 over 2. If I multiplied by the other denominator, it would just be multiplying by 1, right? And this becomes 4 over 2, and then you could add the tops, 5 over, add the bottom. No, you don't add the bottom. Leave the bottom the same, 5 over 2. Okay, so what if I had 3 6 plus 1/3? If you just stick to robotically doing what I said, you'd multiply by the other denominator and you'd use 1/18. But do you get there's a faster way? I mean, I can times by 6 and times by 6 and then times this by 3 and times this by 3, but that's not nearly as easy as just doing what? Think about it. Times that one by what? 2. Do you get then they have a common denominator? I don't have to mess with the other side. All right, so I'm going to give you one like that. 4 fifths plus 6 tenths. Would you please add those together and do it the smart way? Got to get a common denominator. I know it could be decimals, but you can't do decimals for fractions that are trig. Like, there's no way, you have to get common denominators for trig, so that's what we're practicing. So please don't make these into 2 decimals. Even though if it was the ACT test, I would totally just make these into 2 decimals because they add so much faster and easier. But the point here is to learn common denominators. Timesing this by 2. Did you figure that out? So then this is 8 tenths, and then this is tenths, and then they're common denominators. So then 8 and the 6 makes 14 tenths. Raise your hand if you had that. Thank you very much. It really helps when you do raise your hands when I ask like that, because if half the class doesn't raise your hand, I think half of you got it wrong, and then practice things I don't really need to. All right, so that's common denominators. And do we always have to multiply by the other denominator? No. Sometimes, like on this one, I just could multiply this one by something and make it so that the denominators were common. All right, the other thing that is really, really important that you have really down well is factoring. And I know it's been a while, so we're just going to plain old-fashioned factor a few things, and they're going to come up again, but with trig. It'll be cosine squared x squared plus 6 cosine of x minus 7. So regular factoring is going to be critical. This is where I should have spent more time last hour, is making sure they remembered how to factor all the different kinds. Because that's what's going to happen in the trig part, is there's all these different kinds of factoring, but they all are trig problems. Turf, do you agree that this has to be an x and an x? Because that makes x squared, right? What in the heck? Okay. And do you agree that this minus 7 is telling me that there'd be a plus and a minus? Okay. And then last but not least, the only way to make a 7 is a 7 and a 1. All right. So we're going to put a 7 here and a 1 here. And then the way you check, I just do this in my head quick. I go x squared, yeah. Outside, inside. It's always about those two. If the outside and the inside work, it almost always is right. So 7x, negative 1x makes 6x. Yay, it worked. Okay? All right, so that's regular factoring. One more. That's fairly normal, but the numbers are not as nice. Wait, sorry. Factor that one. Because in a second, it's going to have a cosine in a couple parts of it. So if you don't know how to do it when there's no trig, man, you'll be really confused. In a second, I'm going to ask you to show the kid next to you and see if you got the same exact thing. Maybe it doesn't factor, in which case it's called prime. But if you factored it, show what you think it is to the kid next to you while I get attendance done. Okay, x and x, 3 and 3, and minus and minus. That may not be the right order to do it in, but it worked because I'm checking these and I'm getting negative 6x, and that's what I should get. And yay. Okay. So there's a reason why we're factoring trig, and it's because these, when you set them equal to 0, I get my answers are x equals 3 and another x equals 3, so there's kind of no point to writing it twice, but I can get the answer. Same thing happens when it's trig. See, what would happen if it was trig is this would be cosine of x, but the squared would be here, and this would be 6 cosine of x, and you'd still factor it, and it'd just be cosine x and cosine x. Why? Because if you multiply it out, you'll get this. All right, but before we get to that kind, I didn't need to know a few more factoring ones, because I was amazed how many people had forgotten this. Would you factor that? Again, this would be like tangent squared x minus 4, and you'd have to be able to factor it. How many of you remembered x plus 2x minus 2? Okay, good. Then do you get that if I had reversed this, 4 minus x squared, then you'd have to have the 2's would have to be first. And then a plus and a minus, and the x would be last. Do you get the logic of that? If these two are reversed to that, then your little numbers have to be reversed, because 2 times 2 needs to make 4. Get what I mean? So it would be 2 plus x and 2 minus x. Let's see if you really got that. What is 1 minus x squared but factored? Remember that 1 times 1 is 1. gotta be good at this factoring before I even start this lesson. Okay, check with the kid next to you. See if you guys did the same thing. For today, would you guys compare diagonal? You don't have a partner?
Oh, wait, yeah, I meant to switch that around.
Yeah, then other than that, I got it, yeah.
And then compare with my other one. Guys already compare? Okay. You both got the same thing? Okay. All right, here we go. 1, 1 to make the 1. Plus and a minus because the answer ends in a negative, so it must be 1 positive and 1 negative. And then it must be x and x, and that's all there is to it. Okay, let me just show you how. If this had been trig, it would have not said x squared. It would have said cosine x squared. Remember, that could mean the cosine was squared like this. We just choose to write it in the blue way where the squared is on the cosine. Do you get if my problem was this? My answer would have just been this. Because cosine times cosine makes cosine squared. That make sense to you? All right, let's see if you really got that. What's 1 minus sine squared of theta? Factor it. If I would have just started without any what's called scaffolding, that's like building up the ladder to get you ready to be where we are. I think if I'd have just said factor that, nobody would have got it right. But I think now, at least 2/3 of you are going to get this right. So let's find out. Please compare with the kid next to you, see what they thought. One and a 1, plus and a minus, sine and a sine. There we go. Cool, it factors. Why would you care? What if this original problem had been over 1 minus sine? If you factor it then to what we just did, it would have a 1 minus sine on the bottom. Do you get that would very conveniently cancel that, and then your answer simplifies? That's what today is like. The problems look like this, which look really confusing to start with. Then I'm going to remind you of my favorite saying, if you can factor it, you should. And this top part factors to this, and then look. The reason we factor stuff is sometimes to solve it, but sometimes to just cancel stuff, and this cancels. All right, there's one more kind of factoring that I didn't practice with last hour, and then it came up, and then it wasn't good. So let's practice this kind. 2x squared minus x minus 1. Factor that. I'm going to pause for a second while you try that. Okay, please compare that to the kid next to you. I bet a lot of people forgot the 2x and the x, but some of you remembered that. And then this is negative, so you have to have a plus and a minus. See how I'm forced into all these choices? And then a 1. The only way to make that is a 1 and a 1. Now, the only thing I could have wrong is that the plus might be here and the minus might be there. So, like, I got to check it. Always check it at the end. So I'm going to check. Here, 1x. There, minus 2x. Together, I got lucky where the negative was. If the negative hadn't been in the right spot, I would have had to switch them, but it was. How many of you actually had that one right? Okay, sweet. Now, just imagine for a minute that this said cosine in here, and this said cosine right here. Do you get I just have to squeeze a cosine right in front of the x and a cosine right in front of the x, and that would be it? It's the same exact thing, it's just that it's got trig on it. So here's 1. Actually, yeah, I think we're ready to actually start the lesson and have this not be like insane. Oh, wait. One more thing. One more thing I wish I would have started with last hour and I didn't. Do you get this is the biggest thing on that sheet, sine squared plus cosine squared? It's the biggest thing because it can lead to like the one with the coat is cozy and the one with tan is what you seek, and then you can replace sine squared with things. Anytime you see sine squared, you can replace it with other stuff. All right, please write this one down. And I'm gonna make sure that you get the two rearrangements of it that are the most commonly used. What I mean by that is I think you all know that if I said 7 times 8 is 56, that could be rearranged. If I divide both sides by 8, 7 equals 56 divided by 8. That's just the same fact, but rearranged. Do you get what I mean by that? 7 is 56 divided by 8, but all the numbers are in different spots, but it's still a fact. So, would you please take this thing I just asked you to write down, and would you please solve it for cosine squared? Get the cosine squared alone. All you got to do is something to both sides, and cosine squared will be alone. To get this alone, Ava, what do we have to subtract from both sides? Yep. Technically sine squared. And that cancels that, and cosine's alone, and I'm not going to rewrite it just to save time. Do you agree that wherever I see cosine squared, I can put 1 minus sine squared? It's a fact. This is just equal to that. So whenever I see cosine, I can put that. Without even having to rewrite it, I bet you could figure this out. So what's sine squared the same as? Kind of like that, isn't it? If cosine's 1 minus sine squared, sine be 1 minus cosine squared. So on today's homework, there's going to be a ton of times where you have sine and you want cosine. Can you just take out a sine and put in a cosine? No, they're not the same. But can you take a sine squared and replace it with 1 minus cosine squared? Yes, you can. So whenever you want sine to change into cosine, think about this fact. The only fact that has sine squared and cosine squared in it on the whole sheet. Oh wait, you don't have the sheet. I'm going to remind you, take out your half sheet. I gave them to you the other day. I totally get some kids have lost them. But at last hour, only 2 kids needed them. So yay. Maybe I'll have a few more kids that need me to give them one. Please look. If you have lost it, it's okay. I'll give you another one. And pause for a second while we get those sheets out. Okay, so now, if I were you, I would add this to your little sheet, that sine squared is 1 minus cosine. I'd just write it right on the sheet. You won't be able to use that sheet. I'm going to be giving you a clean one so that kids don't write a bunch of answers on their sheet, you know. So I'll be giving everybody a fresh sheet. But for tonight, and we have another week worth of this class before we test. This little half sheet that you've got, or if you've got it digital, put it into a way you can write on it so that you can write sine squared is 1 minus cosine. And the other one, cosine squared, is just 1 minus sine squared. Those are what I would just call rearranged this. There's just a rearrangement of this top one. But what if you need cosine alone? Do you want to have to do a math problem to find it? It's not that hard. Just to get this alone, you would subtract sine squared from both sides. But here, it's all done. Wherever you see cosine squared, you can put 1 minus sine squared. All right, good. Now we've done all the groundwork so that what I show you next is now doable. Otherwise, these were just brutal notes to go through just right off the bat. If I had just said factor that, I think you might have been lost. But now with all that practice ahead of time, I think you can do it. Whenever you're doing something that's very difficult, just get yourself to do one step at a time. I'm doing this huge project for renewing my national board thing. One step at a time. You know what one of my steps was? Get those sheets printed so the kids can sign them. Another one of my little steps, get them handed out to everybody. And I know some of you are like, oh crap, he's gonna ask me that sheet and I haven't signed it yet. I seriously have only gotten 2 back so far, which I understand. It's going to take a while, but you've got to get that thing signed. It's going to make, I'm just going to keep on reminding you over and over and over. Eventually, I'm going to make you like write something on your hand or something to remind yourself. Put it in your phone. Do something to get yourself to remember it. But I'll ask you again as you're walking out the door, and I'm hoping a few more kids will have got that thing signed. All right, so you should start with cosine and cosine. And then it can't be a plus and a minus because that would make this negative. So pluses, no, because this is negative. So it must be minus, minus. And then last but not least, 1 times 1 makes 1. Now, if you're not sure if it's right, you multiply it out. That's cosine squared. And I said it's all about the outside and the inside. Minus 1 cosine x, minus 1 cosine x, together makes minus 2 cosine x. Yay, I did it right. Raise your hand if you had that one right. Cool. Okay, this one. At first, you might be thinking, I can't factor that because there's 2 different trig functions there. And no, you don't just put cosine on one of them and sine on one of them. That does not work. What the heck are we going to do? Anybody know? Turf? Nope. Can't use tangent. That's a good thought. If we could change both of them into tangent somehow, but cosine can't go directly into tangent. Like you can't just say cosine is 1 over tangent. That doesn't work. But I know cosine and sine together make tangent. I get what you mean. Yes?
Did you subtract cosine?
Nope. Thank you for asking. But what if we could replace this sine squared right here with something else that I just had you write on the sheet? What is sine squared again? One minus cosine squared. Very good. Everybody write that. I told you to write it on the sheet. If you did, you could just look for look for sine squared, and you'd have sine squared is 1 minus cosine squared. So we were not ready to factor it. We had to change it so that they both were cosine. Do you get now the red written problem only has cosine in it? After I multiply this all out and simplify it down, then it will factor. I thought we just had to factor. Nope. Factoring is just part of it. Distribute this. And then put the cosine squared in the front. I think it's going to start like this. And then put the 1 at the end. Put the other thing here. And then it will factor. Just do one thing at a time. This goes to the front. That 1 is going to also need to go with this minus 2 here. In fact, let's just put them together. What is 1 and minus 2? Negative 1. And what goes in the middle of the sandwich? That does. And that's positive cosine x. And now, after that much work, now you can start to factor it. I just swapped sine for what sine is, and I had you write that right on the sheet because I knew this was going to happen, and it's going to happen a lot. Because you sometimes want to get sine to turn into cosine. And now it's finally multiplied all the way out, and I can now factor it. Brady, one step at a time. How do we start?
2 cosine and cosine.
2 cosine and cosine. Perfect. That's the only way you could make 2 cosine squared. Jaden, what's the next thing? And it's the signs. A negative and a positive. Now, I'm not sure which should be first, so I'm just going to put them one way, and if it doesn't work, I'll switch them. Dia, finish it for me.
1.
And have you checked it yet? Okay, then I told you it's all about the outside and the inside, so tell me what these two are. What's the inside ones make?
Negative cosine x.
Yes. What's the outside ones make?
2 cosine x.
You are correct. Now put them together.
Which is going to be cosine x.
1 cosine x. And it's positive 1 cosine x, right? And is that what we wanted? Yeah. See? We wanted positive 1. So we did it right. If that hadn't worked, we would have switched the signs around. Can't switch the numbers. Switching a 1 and a 1 are irrelevant. But we could have switched the plus and the minus if that hadn't worked. But it did work. I know, because we multiplied it out. And the outside and the inside are the main thing that you got to check. That is intense, ladies and gentlemen. Let's talk about it from a big picture again. What happened at the beginning? We couldn't factor because they didn't have the same sign, or the same function. That way we had to switch sine squared out for cosine squared, so that at least it was all cosine. Then we had to rearrange it, put the cosine squared in front, the constant, the whole number at the end, and then we could factor it. Look at this next one. One of these is on your sheet. But if you switch this for sine, I know, we just talked about that. I know that it's tempting to switch that for sine, but didn't you have sine over cosine and those two don't like cancel each other? So you don't switch the top for sine squared. We got a bunch of really smart kids in here and you're stuck. It's probably because they aren't looking for factoring. It's so often the key, if a lot of people are stuck, including you, you should ask yourself, oh, could this thing factor? It can. Liam, what is the top factor to? Hint, one step at a time. What goes there and there?
Cosine x, or 1 and 1.
Yep, and then the signs.
Cosine x.
No, plus and minuses.
sorry.
That's what I mean, pluses and minuses, so...
1 plus 1 minus.
Okay, good. We know that because this is negative. And then is the cosine. Now I got to tell if I did it right. So you multiply out the first, and that would be 1 squared is 1, and that's 1. Yay. The last make cosine squared, so that's also good. But what about the outside and the inside? Negative cosine x, positive cosine x. They cancel. And that's good, because there was no thing in the middle of this. So this is working. It factored. Maren Sabins, I bet you can tell why it factored. Because we wanted something to happen.
Because it was 1 minus cosine x, so it cancel out.
Just like that. Those cancel. And my answer is down to be simpler than it was. It was really complicated at the beginning. It was 1 minus cosine squared over 1 minus cosine. And the answer is 1 plus cosine. Do you get a lot of kids think, oh, I can just cancel this and this, and then this and this? That's not at all right. You'd have a minus in your answer, and it's actually a plus. So no, don't try to just cancel them. You've got to factor it, because if you can factor it, you should. And once it's factored, then stuff cancels. All right, next one. It does say factor, but you can't just start with factoring. Rusty, counting on you. What do you think's the first step? Yes! 1 minus cosine. Why did you think that was a good idea? You were right, but why? What made you think to do that? Because the bottom had a cosine. Yeah. If we can make the top and the bottom both have a cosine, then there's a chance we can make them cancel. Graydon, can I just cancel them right now? 1 cancels a 1? No. You can't. It would be kind of like this. If I had 1 plus 7 over 1 plus 8, can I just cancel my 1s and say it's 7/8? No. It doesn't work. It's not the same. You can't do that. You have to factor it, and then you can cancel stuff. And if you can factor it, you should. 1 plus cosine, 1 minus cosine, 1 plus cosine on the bottom, and just copying here. And then that cancels that. 1 minus cosine. Okay. So far, we haven't seen a single common denominator, but we started the hour by talking about common denominators. So they're coming. Right there. Now, would you agree that they currently do not have exactly the same denominator? All right? Lux, can you tell me? This is one of those kind where I can just multiply one side by something. What do you think?
If you multiply by cosine of x.
Yes. If I just multiply this by cosine of x, I would have made a grave mistake.
You have to multiply the other one too.
Yes.
But that gives you sine squared of x over cosine of x on the right.
All right, so one thing at a time. That is for sure cosine squared, and now they have a common denominator, and so I'm just going to start with that. Do you get the cosine times cosine makes cosine squared? So I'm just going to start with that. And I know it simplifies more, but I'm just going to get them to both say cosine squared. Satisfying to me anyway to be like, okay, now they both have a common denominator, so now I can put them together. But this is so messy. What could secant be replaced with? It's off the sheet. But I just would like you to just think, isn't that a sister function? Couldn't I swap it out for its sister? Secant is the same as 1 over cosine. Now watch, if I have a cosine and I swap out the secant for a 1 over cosine, that's one of those special kind. If I have cosine times 1 over cosine, the cosines cancel and it's just 1. Now put them all together into one fraction. The common denominator was cosine squared, so it's all over cosine squared. The top is now 1 minus sine squared. And I could see a kid getting this far and thinking, okay, I guess I got them together in one fraction, I'm done. No, you're so close. Winston, do you know what 1 minus sine squared is yet? Did you write it on the sheet?
Cosine.
Ah, good. It kicked in. And now that it's cosine over cosine, What's the final answer, Winston?
Cosine?
Nope.
Oh,
1. There you go. So many little things you had to notice. Like, remember I had you write this on your sheet? It was said it was going to come up over and over? Why would you have known to look for it? Because you want them to be the same. If I can get this to be the same as this, then they will cancel. All right. On to this one, and this is the first one where there's no denominators, so there's no point in a common denominator, and you can't factor it. So that was the whole big theme for today, is common denominators and factoring. So hint, they're going to be in this problem. They just aren't in it yet. So what could we do that will all of a sudden make this problem simpler? Or maybe just different, so that it has either something that can be factored, or maybe somehow it's got denominators, so we can start doing a common denominator. I want to remind you, it says prove. There's rules on proving. You take the more complicated side and you simplify it down. If I simplify this down right, it should equal cosecant. So I got to simplify something in there. So come on, somebody's got this. Ava, I'm going to give you a reminder, and then I bet you can do it from there. We're going to simplify something out of here, and I gave you a pro tip back at the beginning of this unit. I said if you can get everything to be sines and cosines, stuff cancels. What's the one thing here that isn't following the game plan? No, in the box. I have to take the complicated part, which is in the box. What in the box? Cotangent. Find it on the sheet, Ava, and tell me what cotangent is.
Cosine of x over sin of x.
Yep. Do you remember me saying to get everything to be cosine and sine? Does that ring a bell? That's how you could have known to swap out that cosine, or cotangent, sorry. And I put cosine on the top, and I put sine on the bottom. Now cosine times cosine is cosine squared. That sounds familiar. Cosine squared. We've used that a bunch of times today. Maybe that's going to be a thing. But wait. Now it's got and I'm just going to write, I'm going to draw an arrow all the way down, and I will allow you to do that too. That cosecant is just going to keep on going until we finally have cosecant at the end. It'll just save me time. Okay. I get how this is confusing, like why did I do that? Common denominator time. Do you get that right this second? They don't have a common denominator, but we can make it so they do. Xavier, this is one of those kinds where I could just multiply one side by something. Do you know what?
multiply the right side by sine.
Correct. So we'll put sine x here and sine x here. Now they have a common denominator. And that is sine squared. So far you guys have done this. Every time I've called on somebody, they've been able to figure out the thing. And I'm putting them together because it's got a common denominator, and the common denominator is sine. And now you have to have this moment where you go, oh my gosh, I can make it so much simpler. Dominic, do you know what that moment is? Good guess, but no, you can't factor when there's a plus in there. But I love that you were thinking about factoring, because a lot of times when people get stumped, it's factoring. This one isn't. I'll give you a hint. Somewhere on the sheet is something way simpler. Remember, we're not going to touch the right side. We're only inside this box here. Anybody see it? Yes?
Sine squared plus cosine squared equals 1.
Yes, this whole thing equals 1. You could do that? Yes. Sine squared plus cosine squared is 1. It says it right on the sheet. That's just 1. And a classic mistake would be to just stop right there. Ainsley, why would I have to mark it wrong?
Is the other side is cosine?
Yup. 1 over sine is actually
Cosine.
and this is how you end. Because look, they are identical. Why would you want to go any further? 1 over sine is cosecant. So you can replace this with that, and that's how you end every proof. The exact same thing on both sides of the equals. This cosecant stayed the same all the way down. And the way you get graded is on this part. These are tough. And I'll tell you, it could be worse. I've taught the honors pre-calc version, and you should see the proofs they've got to do. Oh my gosh. This is pretty bad, but it's even worse. But what I was coming into this thinking is, man, this is almost as hard as honors. When it comes to proofs, it's just hard, no matter whether you're in regular or honors. These are hard. Okay. Next one. Do these have a common denominator? Nope. When you see fractions, you should be thinking, well, I could make it have a common denominator. And that's what you have to do. Now, I actually don't want you to finish this one. I want you to this is rare, just watch me do it for a second. I'm going to multiply by the other denominator, which is cosine. And cosine. Why? Because then I'll multiply by the other denominator over here. Do you agree that at that point I would have a common denominator? That and that would be the same. That would be a way to get a common denominator. But this one's so gross it would take us like 15 minutes and we wouldn't start the worksheet. So instead, you aren't ready for something this hard yet, and that's okay. We're just going to remember you could have made common denominators. Now let's go to your worksheet, which is way easier. It's actually a 2-day worksheet. So we were only supposed to do 1 through 8, but I'm going to have you cross off number 8. So we're just going to do 1 through 7, and I'll do the first couple with you. This is one of those moments where you pick your GPA. It's like tonight, because you'll be like, oh, I don't want to do those. Those are hard. And if you decide not to do them, you will get lost. Once you get lost, then all of a sudden the test rolls around and you fail the test. Because this is really hard stuff. But if you keep with me and you do all of these tonight, and if you get stuck, you go check them against the key, which will be posted tonight. This isn't proofs. Proofs, I don't post the answers, I just post some clues. For this, I will post. Oh, by the way, when the worksheets get like a couple days old, then I'll put the keys back up. So if you want to go back and review, those keys will go up. Number 1. Sabins, would you read me number 1, please?
Cosine squared of x plus 2 cosine of x plus 1.
And the directions are just to factor it, right?
Yeah, right in fact.
Okay. Should be doable. Liam, how do you think we should start? What and what?
With the 1 and 1.
Nope, because that's what we end with. That'll go at the end of them.
Oh, just the cosine.
There you go. Now the signs. Noah, pluses, minuses, 1 of each. Correct. Ian, TiVo, what goes in these spots? Yep, 1 times 1 makes 1. And if you want to be sure you did it right, you check the outside and the inside, and you get cosine, and that makes 2 cosine, and it worked. Cool. Number 1's done. Hudson, read me number 2.
1 minus 2 sine x plus.
Sine squared, probably? Or just regular?
No, 2 sine x
Oh, it's not squared. Okay. Keep going.
plus parenthesis 1 minus cosine squared x.
Ooh, I know what they did. They got it all set up to swap out something. Do you get we can't factor it unless it's down to one function? It either has to be sine or it has to be cosine, and I see the switch. Anybody else see the switch? Ava, what switches?
The si- or the 1 minus cosine.
Could be
Sine.
sine squared. And then I'm just copying these. And then you need to put the squared thing in front. Dia, can you rewrite it so the squared thing's in front?
It's gonna be like,
So what do we start with?
1,
Nope, that's not the squared thing. What I mean is that should be in the front.
oh, so it's gonna be 2 sine squared x.
There you go.
Plus 2 sine x,
There's a minus.
minus 2 sine x,
2 sine x
plus 1.
plus 1. There we go. And now it can be factored. All of that work before you even start the factoring. All we did is rearrange it. The sine squared was at the end. It needs to be at the front. Because the squared thing's in front, the not squared thing is in the middle, and the whole number is last. All right. I have a strong recommend that you get this one done and you check it with the answer key tonight so you don't get lost. All right, and also please, please, please remember to bring in your sign permission slip. That's all I got for you for today.